Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 39th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repo in the description. Let's dive in. Problem 39 is integer right triangles. If P is the perimeter of a right angle triangle with integral length sides ABC, there are exactly 3 solutions for P equals 120. And then it lists those, for which value of P less than or equal to 1000 is the number of solutions maximized. Okay, so we need to remember Pythagorean's theorem here, I think. So let me just so C is the square root of a squared plus b squared, or a squared plus b squared equals c squared. Okay. Doopy-doopy-doo. Okay. So what we're going to end up having to do here is, for each number P less than or equal to 1000, we're going to have to see if we can solve for A, B, C given P, and what the solutions are. Let's go ahead and create our file. And we'll go grab our date time stuffs. Always want to begin with these lines. I'm going to set up a limit variable, this time of 1001. Max solutions equals 1. Oop. And I'm just going to have a p-value, and I'll set that equal to 0 initially because we're just going to overwrite it. Okay, so actual logic of how we get there is going to be a for, let's say, P in range 1 to limit. And then for okay, so if we find C, or rather, we guess C, right? Then we can do, like, C squared equals and then we're kind of going to have to guess with A as well. So C is always the larger one. Equals. And then we want to do the square root of C squared plus A squared to find B. And then if B is an integer, then we have a solution. Otherwise, we don't. B equals C squared plus A squared. I might one-line this, but if B mod 1 equals 0, then hold on. Solutions plus equal to 1. Yeah, I'm gonna go ahead and one-line this. There are many other ways we could do this. We could guess A and then B. But if we... It doesn't really matter what order we do the A, B, C thing in. We have to do something similar to this. Obviously, this solution isn't the world's most efficient algorithm. Whether it is exactly what we need for this problem or not. But let's see, if solutions is greater than max solutions, then we want to set max solutions equal to solutions. And we want to set p-value equal to p. And let's go ahead and see what that gives us. Obviously taking a little bit of time here. Not completing in 3 seconds. But let's think through. So C in range 101 to P. Okay, so it is taking quite a long time. wonder... I'm just going to Google real quick. What is the smallest integer right triangle perimeter? C equals 5 is the smallest possible positive integer for which we can solve this equation. And then, so 12 is the smallest possible perimeter, which I think this is even generalized more so than a right triangle, perhaps? Well, maybe not. But in any case, I think that 12 is the smallest possible perimeter for a right triangle with integers. Oh, and it did finish. It took slightly over a minute. And that seems like too many solutions. So let's go ahead and bump this to 12 to see if we can get it under that limit of 1 whole minute. Because that should chop us down a tiny bit on time. And I have a feeling that we're going to want to do this somewhat differently, because I think that we have double counted some solutions here. As in, maybe we got to, maybe starting with the 12, we got 5 for C, but then also 3 and 4. I'm gonna change how I do this. I'm gonna do A, then B. Okay, we did come up with the same answer and it took about the same amount of time, so that didn't quite work. A squared plus B squared, square root of A squared plus B squared. So then if C mod 1 is 0, then we add to the solutions. And I think that won't actually help us. So in terms of, like, efficiency, but it might help us in terms of accuracy. Let's see if we get a different result. I think that we might have to make it so that our solutions are different. So I think I want B to start out equal to A, and that should cut down our time as well. And the reason I said that did this P minus A, it should maybe be P minus A plus 1, but obviously the total perimeter has to equal A plus B plus C. And actually, Okay, so we got a different solution that time, so that's a good sign that we're heading in the right direction. I just added this check because... why not? Kind of want to have this check first, but I don't think it really matters. So let's go ahead and try that. Might still be taking us a little over a minute, but I feel like I'll be more confident in it being a correct answer. And then I suppose there could be... well, I don't think there can be a different C. These might be unnecessary parentheses. We'll find out. Or, well, it doesn't really matter. Okay, so we found 880 to have 8 solutions, which sounds like a much more reasonable number. And that time it only took us 37 seconds, if I'm doing my math right. 52 minus 15. So let's see if 840 is the correct answer. And it is. So, coolio. And apparently only about 78,000 people have solved that before. So, there were a couple of things that we did to maximize, like, we started our perimeter at 12 because we looked it up, and 12 is the smallest perimeter for a right triangle. And then we said, okay, let's start with A. A could be 1 through P. B could be A through P minus A. C always has to equal the square root of A squared plus B squared. C has to be an integer, and A plus B plus C has to equal P. And that gave us enough efficiency, and of course we did our normal, like, oh, if the number of solutions is greater than the max solutions, do a thing where we capture the max solutions and the p-value, which this is throwing me off a little bit because p-value is also a thing in science, so it's not the greatest variable name. I'm gonna go ahead and change that to max p, even though it's not max solutions p. There we go. That's a better name. Obviously doesn't matter at all for the functionality of the program, but like, because p-value is an actual thing in scientific papers, and it is the way that you know whether a scientific paper is, like, good. Well, one of the many ways. It confused me to have the variable named that, even though it was a name I picked. So, confused is maybe the wrong word. I felt like it was confusing to have that name. But in any case, we got the correct answer. We got it in less than a minute. So, I think we're all set here, and I will catch you in the next one.